Well, just to quickly go over again what we hit at the end of the last topic, because this was the big one, is when I made like a copy of an integer, I wrote something, like I had an integer stored in the variable x, I wanted to copy it, put it in a variable called y. I copied the contents of x, which was address 126. So I copied the contents of x and put it in a new memory address that was labeled y. But we also saw that, lists are funny. And other objects are going to be like this too. Lists are funny. I can't fit a whole list in one memory address like I can a single integer for the variable x or y. So instead, I find another chunk of RAM to put the data I care about. Enough RAM there that can store all of it. And then in the actual variable that I have assigned to that object, that thing, that list in this example, I don't have that data. No, what I have is a reference to where I can find the data. So if in this example, Z was the original reference for the list, and it just tells me what's actually stored in Z is the details about that list. For example, it's at memory address 677. So the actual contents of the variable Z is not a list. It's not a list. There is no list stored in Z. A reference to a list is stored in Z. Then if I made a copy of the contents of Z, I made a copy of the contents of Z. The contents of Z was not the list. The contents was the reference. So when I said W equals Z, I did the exact same thing I did with the integer copying. I copied the contents of the memory address associated with X and put it somewhere else. Here, I copy the contents of the memory address associated with, did I just say Z? Let me start again. I copied the contents, when I said y equals x, I copied the contents of x. When I said w equals z, I copied the contents of z. But the contents of z, it wasn't an integer, it wasn't a list, it was a reference. So when you look at this image, how many lists are there? One. Everyone say one. Yeah, it's right there. How many references to that one list are there? Two. That means if I show up and I say, hey, W at index 4 become a P, through the reference to that list W, I go to the list and I modify that one list. But all references, there's only one list. So if I go and print out Z, it's going to go, okay, well, what's at Z? Well, okay, it's the address to the list. There's the list. Well, here's the list I know about, A, B, C, D, P, F, G, H. And if you're saying, but you didn't modify Z, you modified W. No, you didn't modify W. You modified the list W referenced, which happened to be the exact same thing Z referenced. Z and W are just references to lists. They're not lists. And this is very important to understand. Yes?
So, like, is that why, what strings would be like lists in memory, but then that's why they're immutable? So if you have two variables that are like, say, like, if they were lists, so Z is less than W or whatever, it was like equals Z. If you wanted to have, like, change the string in Z, you'd have to create a new string so that you point somewhere else, and the one in W would still be the same.
So the quick answer is yes. Now, strings are actually kind of funny in several programming languages. So if I really wanted to answer your question correctly, there's a billion asterisks involved. So let's not worry about that. But in general, with things that are non-primitive types, yes. So if I go down here, A equals hello, B equals A. There's only one hello, but I have two references. Now again, strings are actually weird in programming languages because there's some like engineering things that happen under the hood that can speed things up a little bit, some like hacks. But there's two references to that thing. Now, what's neat, so here's one of the big values of immutableness, is because strings are immutable, think back to that list example here. When you look at this, maybe you haven't realized it yet, but when you look at this, bear with me for a second. Could you imagine that this situation could create a lot of very bad bugs? If you expected W equals Z to make a copy of Z, it didn't. And if you thought you were modifying a copy, you weren't. You were screwing up that one thing. And that could be catastrophically bad. Not to mention, references, these types of bugs that are caused by like references to one thing, just one sec, are notoriously difficult to untangle. They're very challenging to debug. Some programming languages, this feature of references is a huge thing that they talk about being so good, but it ends up being just a giant nightmare, right? But strings are immutable, meaning I've got two references to the same one thing. So if I were to go and change that one thing, it's going to mess it up for the two references because I'm only modifying that one thing. But it's immutable, meaning I can't go change that one thing. Sure, I only have one copy of that string, which then, if I could modify the string, create that same issue I just talked about with the list. But by the sheer fact it's immutable, it's actually impossible for me to have that problem. I would have to make a copy of the string, right? If I wanted to really do that. But by virtue of being immutable, it eliminates so many of the most pain in the ass bugs that could happen. Because with a list, if I had what we call two references to the same list, we call those aliases. If I modify that list through one alias and expected to go to the other alias thinking it was a copy, not an alias, that's bad. That's not possible because the strings are immutable here, which is awesome. And that's why in assignment 2, raise your hand if you've been working on assignment 2. Okay, actually, before I continue this, I want to hit your question before I forget it. What were you going to ask? All right, so no, it does. Okay, yes, it would, but I'm going to answer that question in detail because I like that question. But I'm going to answer it in a moment. So, first, okay, raise your hand really high if you've been working on assignment 2. All right, so for those of you that have, who here had their code pass a bunch of tests for like infect or something, and it passed all the tests, but it failed on the test that said like assert not A is B? Raise your hand really high. Yeah, a couple of people. That is because, well, that is actually related to what we're talking about right here. When I check if two things are equivalent, I want to know if the values at all points are the same. But when I check if something is something else, I'm checking if the two things are literally actually referencing the exact same thing. I'll show you. Right? A and B are two references to the exact same one single list. The list ABC. All right? And I'm checking, are they the same? And yes, they're the same. Everything across them are equal. I could also do this. And it's going to be true. because now I actually have two lists, right? I have one list that's ABC and another list that's ABC. And there's two reference variables, but they're referencing separate lists that happen to be equal. So far, so good? If this is confusing you, you're thinking too hard. I have two lists and two reference variables. Here, I have one list, but two reference variables referencing the same one list, okay? And they're equal. But if I ask A is B, it's false. Is does not check equality, it checks what we call sameness. It asks, are they aliases? Does the reference variable A reference the exact same thing as the reference variable B? And here the answer is, well, no, because I have two separate lists. But if I did this, it's true, meaning I have two reference variables that are referencing lists, and those lists are literally the same thing. They're the same one list, and that's the difference. So if your tests are failing, if your cert tests are failing that on assignment 2, it's because in the description of that particular part, it says your function needs to take the city and then return like a copy of that city that's been modified. We don't want to actually modify the original one. We want to make a copy. So those is asserts are asserting that the thing you returned is not an alias for the thing you gave as an argument. Because it's supposed to be a copy, meaning it's supposed to be a separate thing. So now if you're thinking to yourself, what if I want to make a copy of a list? Well, there's a lot of ways to do it. The easiest way, I'd say, is to slice the list. Use that slicing technique. Return a list that's everything from the beginning to the end of A. And when it does this, it generates a new list based on that. And if you're wondering, well, why a new list? Well, imagine I said that, right? Print A, B. Well, now I'm slicing A, but it's creating a new list. There, right? So there, that's a quick and dirty way to make a copy. Now, I would look at that and be like, if it was me, I would say the better way is to say copy B. It does the same thing functionally, but here I'm using the, what do we call that thing after the dot? It's called copy. What's the name that we use for that type of thing? A method. It's not a function, it's a method. It's a method that acts on the implicit argument that is A, which is that list. Well, no, actually A is a reference to that list, but yeah. So who wants to know why I say that's a little bit better than the slicing? What were you going to say? Yeah. What? Oh, you want, no, wait, did I say who wants to know? Who can tell me? I was so confused. I'm like, this is weird. What's going on here? That's on me. Who can tell me why I think saying .copy is better? What were you going to say? To me, it's clearer code. If I'm a Python programmer and I see the slicing, I'm going to know what that means. But maybe I'm a programmer that's used to another programming language that's similar. I see the slicing, I'm going to go, what the hell is that? That's a Python thing. That's a very Python-y type of code. Where .copy, sure, that's a method for a list in Python. But if you're not familiar with Python, and I see a.copy, I'm going to go, that probably means make a copy of that thing. It's a little bit more self-explanatory. Now, you had a question about copy versus deep copy. Deep copy will work the same way in this particular scenario, but deep copy actually means something a little different. Oh, what is? Oh, maybe. Yeah, from the copy library, sure. I won't do it here, but I'll explain the difference. So, imagine for a second I'm going to try to draw it in Paint. This might go very poorly. All right? Bear with me. So I have some variable A. And if I say A is a list, I've got the list. Now remember, A is actually a reference. So I'm just going to represent the reference as this like arrow. Okay? That arrow was supposed to be wobbly. And in this list, I have like X, Y, Z, right? And if I say A.copy, well, that's going to go to the thing A references and makes a copy of it. It's going to go, okay, copy of this thing, well, that's X. Copy of that thing, that's Y. Copy of that thing, that's Z. So it goes and makes a copy of the list, and maybe I said B equals A.copy, right? So if I said B equals A, I get this. If I say B equals A.copy, or I do that slicing thing, I get this. We can agree those are two very different things. In this example, I have A and B. They are variables. They're both reference variables to lists, but they're referencing separate lists, different lists. They happen to be equal, but they're different. Oops. The other one, two reference variables referencing the same list. Now, the issue happens is, well, you know, we learned about this whole reference thing, right? I have, like with strings, strings are going to work like this reference thing. Lists work with this, like A isn't actually the list, it's a reference to a list. A lot of things, a lot of types in Python are going to work with this reference thing. But for the sake of argument, imagine I had a list of lists. All right? So I'm going to actually move this. Like I had A equals 0, 1, 2, 3, 4, 5, 6, 7, 8. So what do we see here? First of all, what is A? Who said a list? Raise your hand. Who said it? Try again. It's a reference to a list. It's not a list. It's a reference to a list. Because we can't store a list there, right? We got that whole reference thing going on. So now, I look at that list and I go like, okay, well, what is A at index 0? Someone tell me. What's A at index 0? It's another reference to a list. I go, well, it's the list 0, 1, 2. And I go like, well, it's not though. It's a reference to the list 0, 1, 2. So I'm going to draw this in Paint. You can all see this is working for you, right? All right. Yeah. All right. So if I have the list 0, 1, 2, for the sake of my patience, I'm only going to do 2 lists. 3, 4, 5. In that particular example, what I really had was, again, assuming I only actually did it with 2 values, that's what I had. So a list of lists, you can have a list of references to lists that have references to other lists that have references. You can do this forever. But this is really what I have when I have like these reference types, okay? So here's the problem, and this goes to the deep copy question. If I said B equals A, right? So let's say I've got B, and I say B equals A, this is what I get. I create an alias for that list, right? No, I don't want that. I want to make a copy. Okay, you want to make a copy of A? So we're going to go to that list and copy the contents over. So here's what we're going to do. See if I can get this to work nicely. Now, what was A at index 0? Yeah, we copy the reference. Take a moment and look at this picture and understand why this could be a problem. The internal lists were never copied. I copied the references to them. So this is going to your question about deep copy. If I copy the list, I make a copy of that top list. And that top list contained references to lists. So copy those references. All I did is I made a new list, but the contents of that list were aliases to the smaller lists in the other one. Does that make any questions about this? This is very important. We're happy? We're good? So this is where deep copy comes up, where you go like, okay, make a copy all the way down. Meaning, I would do a deep copy if I wanted to make a copy of everything. I'm going to run out of room. But I would make this, I would copy all of this. I'll just move it down here because I'm out of room. Nope, couldn't see my cursor. There, right? It's off the screen, but whatever. So a deep copy would go and make a copy of everything all the way down. So that's what a deep copy is versus a shallow copy. And let's see if we can test this, because I'm actually not sure what I actually don't know what the default copy method does for lists. Let's find out if it does a deep copy or a shallow copy. So, okay. First of all, B equals A. Okay, print A equals B, A is B. Based on this, here's the test for you. When I hit run, what will we see? Here. There. I added a third one. There's 3 conditions here I want to check. All truths. So A is equivalent to B because they're literally the same thing, meaning the next A is B. And then A at index 0, which is this list, is it the same thing as B at index 0? So let's see. True, true, true. Okay, cool. So let's see what happens if I say A.copy. So based on what we've seen so far, I am expecting A equals B to be true. They're equivalent. I made a copy. So they'll be equal because it was just a copy. A is B should be false because I made a copy of that big outside list. But I'm actually not sure. My gut tells me A at index 0 is B at index 0. My gut tells me is this is doing a shallow copy, meaning this should say true. But if it's doing a deep copy, it'll be false, meaning it actually went and made a copy of this list. So let's find out. Look at that. True, false, true. My brain doesn't work today. What did I just say? What I'm seeing is what I expected to say, what I expected to see, but I may have actually said it wrong a moment ago. Let me clarify what I mean. A is equal to B. Yes, it is, because I just made a copy, and if I made a copy of something, they're going to be equal. I didn't do anything different in the meantime. A is B. Well, that's false, because I made a copy of the outside loop, right? Meaning, is A and B, they might be equivalent, but are they literally the same thing? No. Then I ask, A at index 0, is it B at index 0? Ugh. Here, I'm going to draw out what happened. We made a copy of B, or sorry, we made a copy of A, and the contents of A were references. This is the situation. My gut was right. A and B are equivalent. They are not the same list, though, right? Because A references this list up here. It's impossible to see the cursor, isn't it? It's referencing, A is referencing this list, but B references this list. So they are separate. But A at index 0 references this list, and B at index 0 reference that same exact list. So true, false, true. It's true that they're equivalent, false that they're literally the same thing, but the internal lists, I only ever copied the references over, meaning that it was a shallow copy, meaning that they were literally the same thing. And then let's see if we can do the deep copy. Deep copy, A. True, false, false. So when I used this copy library's deep copy function, so I'm now I'm using a function from the copy library. I didn't use a method. I didn't use the libraries or the list's copy method. But when I used the deep copy function, it actually went and did make a copy of the internal one, meaning that the internal lists actually also got copied, meaning they're equivalent, but they're not referencing the same thing. Does that answer your question? I loved that question. That was a great question. Do you have a question now?
Is deep copy technically a method of copy, which is argument?
No, because copy is not a class. Copy is just like a library. It's a suite of functions that people said, let's put this, they're all like copy related things. So let's throw this into a Python script called copy where we'll just store all the copy related things. The difference between like the library and a class is going to become very clear in, where are we? So we're like here. When we get to here, that's when we hit it really hard. So you're thinking the right way, though. Good stuff. All right. So now that the half an hour review is over, let's move to the next thing. So aliases and list trivia. We've talked about a lot of this already. I'm just about to repeat myself quite a bit. A equals 5, B equals A, print A, B, I see 5, 5. B equals 7, print A, B. A is still 5, B is 7. This shouldn't surprise you. Now, this should also not really surprise you. A is that list, but it's not, right? It's a reference to that list. B is now a copy of that reference, meaning it references the same list. Print them out, we see the same thing. If I make B reference a different list, all right, fine. A is left alone. We just changed what was in B. B is now a reference to a different list. A was left alone. But that's what I would see. This shouldn't scare you. This shouldn't throw you off. This is how things should act. And what I'm about to show you shouldn't scare you because it acts the exact way that everything else has acted. But you have to remember what is actually stored in these variables and where that list actually is. This might be what throws you off. In the above example, I changed what B was. I made B Reference an entirely different list. Here, I didn't modify anything about B. Nope, B was left alone. I went to the list B referenced and modified that list. So here, A and B are aliases for the same one single list. I could have 1,000 aliases for the same list, and if through any of them I modify that list, I've modified the one list. All aliases will see, oh, it's changed, it's different. It has a different state now. If it's not clear what the difference is, don't get me wrong, it is kind of nuanced, but if it's unclear, again, you're working too hard. You're looking to connect dots that aren't quite there. It is probably simpler than you think. But you have to remember, when 5 equals x, or x equals 5, I put an integer into x. If I say some y equals some list, I put a reference to that list in y. I didn't put the list there. It's very different. Here, I modified when I said B equals this new list, I changed what was in B. I created a new list, it went somewhere in memory, and I put a reference to that new list into B. Here, I didn't touch B. B was left alone. The reference variable B, nothing about it changed. But I said the list that you reference at index 1 changes. This, I actually modified the list, not B. B is just a reference. Here, remember, A and B are both referencing the same list. They're aliases. There's only one list, but I have 2 references to that one. Regardless of the variable used to modify the single list, that list is altered. If you expected B equal to A to make a copy of this list, you're going to be unhappy. But it doesn't. And it shouldn't have, because that's how none of this would have worked so far. Even though it seems like it was with integers, it's because when I stored an integer in the variable, I stored the integer in the variable. When I stored the list in the variable, I didn't store the list in the variable. I stored a reference. So when I said B equals A, I copied the contents of A. The contents of A was not the list. It was a reference to a list. That's all. So if you expect this to make the copy of the list, you're mad. If you expected this to make a copy of the contents of A, which is what you should expect it to do, you're happy, because this makes perfect sense now. All right, okay, big thing. If you're like, okay, well, whatever, I'll just try to remember this, and let's move past it so I can keep paying attention to what's going on. I got bad news for you. This is basically going to be the way it is from now on. All right, this difference, if you're like, oh, the devil's in the detail, what is like a minor nuance? No, 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 no. This is the way it is from now on. We got to be making sure we're clear about what's a reference and what's a variable. And is it a reference variable, or is there just a value in that variable? What is it? What's actually stored? This is going to be critically important. I'm not expecting you to understand this 100% today. What I am expecting you is to understand this 100% soon. The more practice with it, it'll make sense. If it wasn't obvious, assignment 2 really emphasizes this whole variable list. Is it a reference? Is it not? Assignment 2 has a lot of that in it, because you got to get practice with this stuff. Each assignment is well designed to emphasize a certain thing. Right? So the next assignment is more on this list stuff, even heavier with this alias stuff. But it's really big on forcing you to like debug, because the next assignment, the third assignment, students tend to find really tricky for a very specific reason. It's because people are messing this up. But The third assignment really forces you to debug. You're going to be wrong a lot, and you're going to be having to debug. But the debugging process is nice and easy because you visually see, I know what I'm supposed to be seeing, and when I run it, I see this. And then when I make this change, now it looks like this. So it makes it a little clearer how your changes visually are affecting it. Anyways, whatever. If you do want to make a copy, you've got options. I would say this is my preferred way. Use the copy method. You could also import the copy library and use the copy method there. That's fine too. But you know, you got the method. It's there already for you. All right, so here we go. We'll skip this because I literally just did this a bunch of times. So, functions and aliasing. Here. Right? I have, on line 4, I created a list, the list ABC, and I put a reference to it in the variable aList. And then I gave that reference variable to the function addToList, along with the argument 99 that I wanted to append to it. On line 5, when I call the function, what value does the parameter value get? This isn't a trick question. 99. Why? Because it says 99. What value does SUMList get? A reference to a list. There's no copy. These variables are going to work the same way I was just ranting about. Oh, you gave it this list as an argument. No, I didn't. I gave it a reference to that list. Meaning, when I say SUMList.append, we can even maybe try to make this more obvious. Take a moment, look at this, and based on everything we've seen, you should be able to make sense of why we're seeing what we're seeing on the output here. I created a list on line 5. On line 6, I gave a reference to that list to the function addToList. So in that function addToList, I have the variable SUMList, but it's a reference to a list. So I told that reference, hey, append to that list the value, 99, and then I returned SUMList, whatever. And then back on line 6, I stored the value that was returned into the variable blah. I printed out blah, and then I printed out a list. And we can see, well, both lists were modified. There's no both. There's only one list. How many different reference variables are there? On all of this code, including inside the function, how many lists are there here? Everyone, raise your finger. I'll give you a big hint. 1. There's 1. But how many reference variables to that one list can you see in this example here? Raise your hand if you see 2. Raise your hand if you see 3. There's 3. There is the reference variable aList. There's the reference variable SUMList. It's the parameter. And then there's the reference variable blah. All 3 of those actually reference the same one single list. Now, don't get me wrong. When the function's done executing, the reference variable SUMList disappears. So maybe 2 is kind of right. But really, in total, there were at one point, there were 3. And for those of you that were working on the assignment, and you were passing those equality tests but failing those is tests, it's because you were doing this. Maybe what I should have done was Now we see something different. I made a copy, put the copy's reference variable back into the original reference variable, the sum list, and then modified the copy. And now we see, well, blah was the modified version, but a list wasn't. It was left alone. Oops. If I make a copy of it, it's returned. Append the value, sum list. Yeah, that's right. That wouldn't work. I was just testing something real quick there. Anyways, you got to be careful with this. This is what we call an impure function. There's nothing intrinsically wrong with impure functions. This function has a side effect. Remember I was talking about side effects earlier in the semester with like I/O? Like a function, to be a pure function, you know, your function gets some input, does something, and produces some output. It leaves the input alone. It doesn't touch the input. It doesn't touch anything else in your code. It gets some input. Based on that input, it does something, it returns something. Everything is treated very independently, though. The output is independent, like it's based on the input, but it's separate. The function didn't modify the input. The function didn't modify anything else anywhere in your code. That's a nice pure function. We like pure functions. An impure function is one that starts screwing around with stuff, which isn't necessarily bad, except for that it's, you know, ripe for errors and issues and headaches and a lot of problems. So the value of having a pure function is it tends to be a little easier to work with, a little safer. This is an impure function. First of all, it didn't return it. Actually, no, it did return something, but it returned a reference to the same one list. This function modified the input value. That's not bad, but it did. And that could be an issue. So add to list an example of a function that has a side effect. The function modified the list that was passed by reference, and the term side effect comes from the mathematical expectation of a function. A function just maps some parameter, some arguments, onto a value. If I give you the function f of x, y, z equals x plus y plus z, and I ask you to evaluate f1, 2, 3, the value of x, y, and z don't change. That's a stupid thing to suggest in math. But in our example here with the list, the value of the thing that some list referenced was modified. And again, that's not necessarily a bad thing, but it could be the root cause of a lot of issues later. So a lot of people would argue, look, it's not bad to do it, but just save yourself a headache tomorrow by writing pure functions instead. Anything you do with a pure function, you can do with an impure function. Anything you do with an impure function, you can do with a pure function. It's fine. But it's a little better long-term usually to have nice pure functions. And they're easier to test, too. It's easy to test, like, here's the function, here's the input, this is the output, what I expected, good. Well, what happens if you're checking the output, but it also modified the input? And how am I going to test that? That's crazy. I need to go, it's going to be a lot harder to test, and if you have code that's hard to test, good luck. So here's an example of a pure version of that function. I kind of showed this to you already, but this one created a new variable name. Sum list, we made a copy of the contents that it referenced. We modified the copy, returned the copy. A list was left alone. Other list, well, that was the one that this function returned. Now, what I want to emphasize right now is the function is pure. Now, you might look at this function and be like, okay, it feels like what I'm doing within that function, it feels like, well, what you're doing is a bit of a roundabout way no, how do I explain this? This one's kind of tricky to explain. Give me a moment while I try to come up with a good explanation here. This list is not, lists are mutable. There's nothing that would have stopped me from writing a function that was impure. Because lists are mutable, it's fine. But in spite of being, did I say immutable? My brain isn't working today. Did I just say immutable? Lists are mutable. Listen to me now. Mutable. They're mutable. We could change them. Oh my God. Jesus Christ. So, lists are mutable. There's nothing wrong with that. We like that. That's a good thing. But this function treated the list, it didn't have to treat the list as if it was immutable, which it did. It treated it as if it was by making a copy and modifying the copy. We didn't have to do that. We could have made this function impure. There's nothing wrong there. But we like the pureness. It comes with a lot of advantages, especially later down the road. So we like that. So this function was written in a way to treat that list as if it was immutable. I think I used the right words this time. Meaning, I called that function left a list alone. It didn't have to, but it did. And it modified the copy to make it seem as if, oh, you know, I made a new version of the list that was modified. I don't know, it's kind of hard to explain, but maybe with more experience, this will just kind of make more sense to you. I could have made it impure, and maybe you're like, it would have been so much easier. Yeah, but this is better. Trust me. Trust me. And I mean, here's what's going to happen. Raise your hand if you're going to take 162. Raise your hand if maybe you'll take 255 after that. That's like the next course. Yeah. So, you know, you continue programming and whatnot. You keep going, you're programming. And one day you're going to be like, James was stupid. I'm going to make an impure function. It's better this way. I just know it's better this way. Fine. Fine. You do that. And then maybe it'll be 1 day, 2 days, 3 days, a week, a month. At some point in time in the future, it's going to bite you in the ass. And I want you to remember, on October 18th, 2023, at 2:19 p.m., you can go watch it on YouTube, I told you. Don't do it. Don't risk it. Make it pure. Do yourself a favor. Do yourself a favor. Trust me. Cool. All right. I'll see you later.